Hey guys, so today we are going to be looking at a new chapter. We're going to be starting our second chapter, and that is chemical equations. Okay, so to start us off, we are going to talk about chemical reactions or chemical changes. Somewhere we'll have studied about how physical and chemical changes are different, right? So today we'll be performing three experiments, three activities to take a look at what a chemical change looks like and how can we identify a chemical change by what we observe or what we see. Okay, so these are the three setups for three activities. I'll go through each one. So this is a chemical called calcium oxide. It's a white powder. Okay. Now what I'm going to do, I'm going to take a beaker and I'm going to add a little bit of calcium oxide inside of this beaker. Oh, it's a lot of it. Okay, all right, not an issue. Now what I'm going to do, I'm going to add some water to this calcium oxide. Okay. Now, once I've added calcium oxide to water, I'm going to wait for it to react a little bit. Okay. Now, this calcium oxide, once it reacts with water, it forms something called as calcium hydroxide. Now, you can't really see it in the experiment, but if you ever do this activity on your own, you'll see that this reaction makes the container a bit warm. Okay, right now it's becoming a little hot. It's just enough for me to touch. You can't see it, but I'm sure if you ever do it, you'll be able to observe, right? So sometimes when a chemical change occurs, you'll see that the containers is going to become hot. Okay, so we call these as exothermic reactions. So anything that creates a heat in the reaction. That is the first activity we look at. Now I am going to go to the second activity. For the second activity, I am going to need two chemicals and two beakers. Now, so one of these chemicals, this is barium chloride, and this one is sodium sulfate. Right, the names will be written on the containers. Now, both of these are salts, crystalline salts. What I am going to do, I'm going to take some of each chemical and I'm going to add them to each beaker. Okay, so for the first one, right, you see these nice white crystals, okay, of barium chloride. Now I'll also do the same for this sodium sulfate. Okay, right, this is a white salt, you notice, right? Okay, this is a nice rock. Yeah, so now in both of these containers I've added different chemicals. I'm going to make a solution of these two chemicals. When I say solution, I mean I'm going to add water to it, that's all, nothing more than that. Okay, now as my water, a little bit to this, some in this. Okay. Once you add water, we just shake them, stir them a little. You can use a stirrer or you can simply just stir the beaker like this. Either way, we make sure that they are dissolved. Okay, you'll see that now it has reduced, most of it is dissolved. Same for the other salt also. I'll just make sure that all of the salt is dissolved. Now what I am going to do, I am going to add one of these solutions to the other solution, right? We're going to add one solution to the other solution, and we're going to see, is there anything at all that is happening that we can notice? Is there something visually different about this reaction? Okay, now watch carefully as I add. I think you observed something, right? Something has changed about this. It's a completely white liquid now. We started with two solutions, both of them had no color in them, right? Transparent, just like water. When I added them, you see now I am left with a white kind of milkish color liquid. I'm going to let that sit for some time. So if you look at this closely, at the bottom of the flask you will see there is some white sediment forming, right? Some white layer. So if I leave this for longer, it is going to settle down just as this white matter at the bottom, like sand. So that is called as precipitate. So if a precipitate is formed, that also tells us that it's a chemical reaction. I'm going to move to the third and last experiment for today. For the final reaction, I'm going to need zinc, acid and a test tube. So I'm going to use a test tube holder to hold the test tube, and first I'm going to take this zinc powder. It's a metal which is in powder form. Then I'll take the test tube and I'll slowly try to pour all of this metal into this test tube. It's harder than it looks. By the way, it works with any metal, not just the zinc, and whether it's powder form or solid form, this experiment will definitely happen. So now I'm going to close this and take a little bit of acid. Now hydrochloric acid is quite strong, so you have to be very careful when you use it. So I first pour it in a beaker, which helps me pour it into a test tube easily, and I'm going to be very careful while I pour it. Now once I am done pouring, almost immediately you will see the reaction starting. You can notice a few bubbles that come out. Now I'm going to close this test tube with this green balloon, and I want to see what is coming out, because if there are bubbles, it means something is coming out of the tube, right? Now once you wait it, you will see that the balloon has slightly inflated on its own. So to summarize everything we have looked at so far, a chemical change can be notified by a change in the physical properties of the reactants. It can be color, it can be state of the reactants. It can also be denoted by the evolution of a gas. It can also be denoted by the precipitate being formed, right? Like we saw the white colored precipitate that came, and it can also be denoted by simply a change in color or any physical properties that we can visually see in the reaction. And finally, heat being generated by the reaction. So either the container is going to become hot, or we might need to give heat for the reaction to happen.